Hello everyone, my name is Chris Hickson and this is the study guide for 5th period. This study guide is going to cover area, volume, and surface area. So the first question on our study guide gives us a triangle. I'll just draw the triangle out here as best I can. Ooh, that's not very straight. We're going to pretend this line is straight. Sorry about that. I'm sure that won't be the only time this happens. And it gives us the dimensions of this triangle. And the dimensions are 6 and the height. Oh man, that was not good either. Let's see if I can do this. Yeah, close enough. And the height is 3. So what we need to do is use our area of a triangle formula, which, if you recall from class, is area equals base times height divided by 2. And instead of the base, we'll plug in our 6 feet. And instead of the height, we'll go ahead and plug in 3, since that is our height. Then we'll take that divided by 2. 6 times 3 is 18. So our area is 18 divided by 2. 18 divided by 2 is 9. So now we bring back our unit, which is feet. And since it's area, it's feet times feet, which is going to give us feet squared. And that's our final answer for number 1. Jump on to number 2, and I will catch up with you. Oh, oops. Alright, so number 2 is also an area problem, and it gives us a circle, and I'm going to try my best to draw a circle here. Yay! Sort of. We can clean that up a little bit. So this circle gives us the diameter of 10 centimeters. And while the diameter isn't really something we used, we did talk about the area of a circle, which is area equals pi r squared, r being the radius. And remember that the radius is equal to half the diameter. So our radius is going to be half of 10, and half of 10 is 5. So our radius is 5 centimeters. So now we can go ahead and plug that into our equation for an area. Area is equal to pi, and instead of r, we'll go ahead and use what it's given us, which is 5 centimeters. And we are supposed to square that. So now we can go ahead and do that. A is equal to pi, and 5 squared is 25. And typically you'll see this rewritten as A equals 25 pi. We'll bring down our units, centimeters, and because we're talking about area, it's centimeters squared. And that's that. Alright, I'm going to jump to number 3, and you go ahead and start it. I'll get this stuff erased, and I'll catch up with you. Alright, number 3 gives us this sort of odd-shaped box thing. I'll go ahead and draw it out for us. And it gives us some of the parameters. It says that this is 10, this is 15, this is 4, and this is 6. And they're all in meters. So the first thing we need to do is identify the things that we're missing. Well, we know that this is 4, and this total piece is 15. So then that means that this must be all of this, 15, minus this little piece that's not up here, 15, minus this little piece, minus 4, is equal to 11. So I know that this entire piece is 11 meters. Now I can do the same thing over here on the right side. I know that this length is 10, and I know that this length is equal to 6 plus some number, and that's going to equal 10. So I know that 6 plus whatever this is going to equal 10. Well, just by using my powers of counting, I can count upwards from 6, and I know that 6 plus 4 is equal to 10. Therefore, this must be 4. So I'm going to go ahead and redraw this and plug in the numbers we know now. Alright, now I can go ahead and turn this into 2 different smaller squares, or rectangles rather. Now, using this formula, or this cut, I guess, for the square, I know that this square is equal to 4 times 4. So this square is going to equal 4 times 4, which is 16 meters squared. And then I also know that this square is equal to 11, because that's the length here, times 10, because that's the length here. So this square is going to be equal to 11 times 10, which is 110 meters squared. Now I can add these two numbers up to find the total area. 110 plus 16. 6 plus 0 is 6. 1 plus 1 is 2. Bring the 1 down. My area is 126 meters squared. And that's the end of number 3. You can go ahead and erase this, or start on number 4 while I erase this stuff, and I'll meet you there. Number 4. Number 4 has a house, so we'll go ahead and start on number 4 while I erase this stuff, and I'll meet you there. Number 4. Number 4 has a house, so we'll go ahead and draw that house. And I'll just go ahead and draw the dotted line here to complete the house. I know that this is 9, and the side of the house is 6, but I know that from the floor all the way to the roof of the house is 10 units. So because I know that the side of the house is 6 units, I know that this height must be 10 minus 6, which is equal to 4. So I know that the height of the triangle must be 4. Now, to find the area of the bottom part of the house, the square, or rectangle, actually, I know it's going to be 9 times 6, because this is the length of the house, and this is the width, or the height, I guess, of the house. So 9 times 6. And 9 times 6 is going to be 54. Once I've done that, I need to then find the area of the triangle, because we've only found the area of half the house. We still have to find the area of the triangle. And if you recall from our work in math, the area of a triangle, how am I going to do this? Let's see. We'll do it this way. The area of a triangle is equal to base times height divided by 2. And I know that my base here is 9. And I know that the height we already decided is 4. 9 times 4 is 36. And 36 divided by 2 is 18. So now I can take these two areas and add them up. The area of the base of the house and the area of the upper portion of the house. 8 plus 4 is 12. And 5 plus 1 is 6, plus 1 more is 7. So the area of this entire composite figure, this house-looking thing, is 72 units squared. Alright, that's the end of number 4. You can go ahead and get started on number 5. I'm going to erase this and I'll catch up. Alright, number 5 gives us a 3D figure, and I'm going to just sketch out the net and go from there. Alright, based on the information that it has given me, I know that this part is 6, therefore all of these must be 6. And if this is the bottom of the triangle, I'm sorry, this one right here is the bottom of the triangle, then this must be its width. And I know the width is 4. And then these must be these sides, so up here is also 4. And that would make this portion the height. And I know that the height of this triangle is 5. And that would mean that this is 5 and this is 5. And that this is also 5. And that this is also 5. Up here we need to be careful. So this is the top of our rectangular prism. So these sides are actually going to be 4. Because this face is actually touching this face when we fold it all back up. And this face, or this edge, I'm sorry, edges are touching this edge. Now that we've done this, we can figure out the area of each of these triangles. Or not, whoa, what am I saying? Each of these rectangles. Holy cow. It's late, I'm sorry. So for the first rectangle, we have 6 times 5, which is 30. For the second rectangle, we have 6 times 4, which is 24. For the third rectangle, we have 6 times 5, which is 30. And for the fourth rectangle, we have 6 times 4, which is 24. Now we can go ahead and do the wings. I have 4 times 5, which is 20. And 4 times 5 again. I have to add in that these are also 5. Anyway, 4 times 5, which will give us 20. And now I can add this all up. I've got 2 of these wings, each with an area of 20. And then I can go ahead and add that to all 4 of our other wings. One of them was 24, plus the second one, which was 30, plus the third one, which was 24, plus the fourth one, which is 30. And I can just add these up piece by piece. 20 plus 20 is 40. 24 and 30 is 54. And 24 and 30 is also 54. I can keep going. 40 plus 54 is 94. Bring down this other 54. And then 94 plus 54, 4 plus 4 is 8. 9 plus 5 is 14. So I get 148. So I know that the surface area of this rectangular prism is 148 units squared. And the unit for number 5 is centimeters squared, or centimeters, excuse me. So it'll end up being 148 centimeters squared. Alright, jump on to the next one. I'm going to erase this and we'll start on the next question. Number 6. Number 6 is another 3D figure, and I'm going to go ahead and draw the net for it. So the net looks something like this. It's a little crooked, I apologize. But we know that the length of our triangular prism is 12. So we can fill it out on all of these. And then we also know the height of the triangle is equal to 3. And that's also true for this triangle. And then it tells us that the width of these rectangles is 4. Oops, pick a different color. That's true for all of them. Which also means technically that the edges of these triangles here are 4, but that shouldn't matter in what we're doing. So the first thing we're going to do is find out the area of these two triangular faces. And so in order to do that, I need to do the base times the height. Well, it tells us that the base of these triangles, these poorly dotted lines, is 8. So I know that the area of those triangular faces is the base, which is 8, times the height, which I know is 3. Let me take all that and divide it by 2. 8 times 3 is 24. 24 divided by 2 equals 12. And I know that I have 2 of these faces, so each one of them is 12. Now I can find out the area of the three rectangles that we have. So I know that for each one of these, or for 2 of them rather, we have a length of 12 and a width of 4, and 12 times 4 is 48. So I know that this one is 48, and I also know that 12 times 4 here is 48. Now this inner one's going to be a little bit different. We're going to need to take 12 and multiply it by the width, which is 8. And 12 times 8, well, 8 times 2 is 16. 8 times 1 is 8, plus 1 more is 9. So I know that the area here is 96. And now I can add it all up. 96 plus the 2 triangular wings, which were both 12. 12 plus 12. Plus the 2 smaller rectangles, which were 12 times 4, which is 48. Plus 48 plus 48. 12 and 12 is 24. 48 plus 48, we can go ahead and set that up. 8 plus 8 is 16. And 4 plus 4 is 8, plus 1 more is 9. So 48 and 48 is 96. 96 and 24. 6 plus 4 is 10. 9 plus 1 is 10, plus 2 more is 12. So 96 plus 24 is 120. Now I can add 96 to it. 6 plus 0 is 6. 9 plus 2 is 11. 1 plus 1 is 2. So I get 216. So the total area of this figure, this triangular prism, or the total surface area, excuse me, is 216. And the unit gives us our centimeters, so our units are centimeters squared. And that's the end of number 6. Start on number 7, and I'll catch right up to you. Alright, number 7. Number 7 gives us the same 3D figure that we had before, and we have to find the volume. So we know that the formula for a volume, and in class I called this Destiny's theory because Destiny helped us come up with this, if you remember, is going to be the area of the base times the height. So in this case, we have, let's see if I can draw it, a triangular prism. That's not that bad. And so we need the area of this base, and we need to multiply that times the height or the length of the triangle, or of the triangular prism. And so this triangle has a base of 8 and a height of 3. So we need to do the area of the triangle base, which is 8 times 3 divided by 2. And we need to multiply that by the length, which in this case is 12. Because remember, we're just getting this formula from the fact that the volume, according to the theory we developed with Destiny, is going to be the area of the base, which is base times height divided by 2, because our base is a triangle, multiplied by the length of our triangular prism. 8 times 3 is 24. 24 divided by 2 is 12. 12 times 12 is 144. So our volume is 144, and this gives us centimeters cubed, our units. And that's the end of this one. Get started on number 8. I'll be right there. Alright, number 8 is a similar problem. It's a volume problem again, but this time it gives us a rectangular prism that I will attempt to draw. That goes straight-ish down. This goes straight-ish down. This is not easy. Alright, and it tells us that the length is 3. The width is 5, and the height is 8. Now remember, you can draw the lines if you so choose. One, two, 3 pieces, and 1, 2, 3, 4. You can draw all these out. It's probably a little bit easier for you on paper than it is for me on the computer. But if you've got questions about that, feel free to come see me. But I'm going to want us to remember what we used for our equation, because, again, we refer to this as Destiny's theorem. Not that it's actually called that, but she helped us come up with this in class. Together we realized that the volume of a rectangular prism is equal to the length times the height, or the width, excuse me, times the height. And so now I can just sub in the numbers that I know, and we get the volume is equal to 3 times the width, which is 5, times the height, which in this example is 8. So I know the volume is equal to 3 times 5, which is 15. I bring down everything else. 15 times 8, I'll go ahead and do over here. 8 times 5 is 40. 8 times 1 is 8, plus 4 more is 12. So my volume is equal to 120, and the units it gives us are inches, so it's inches cubed. And that's the end of your study guide, 5th period. Study up, and I will see you for your test on Friday. Good luck.